All right, so let's get started. So this is a brief introduction of PolyU. PolyU is one of the oldest institutes in Hong Kong for higher education. It was founded in 1937 as the first government-funded post-secondary technical school in Hong Kong. It is also very young. It became a university only in 1994. So PolyU is located in a very convenient location connecting the Kowloon Peninsula and Hong Kong Island. This slide gives some landmarks at the campus. For example, we got the main entrance, a library, a teaching and research hotel icon. This is student accommodation, industrial center where you can have some hands-on sessions. So PolyU consists of 8 faculties and schools. Faculty of Engineering is one of the biggest, one of the largest. In Faculty of Engineering, there are in total 7 departments. So we are one of them, Department of Aeronautical and Aviation Engineering, or AAE for short. So we were just born several years ago in 2016. Under the rapid growth of aviation industry in Hong Kong and aerospace industry in China. So we realized that aeronautical and aviation engineers are increasingly demanded. So we are the first department in Hong Kong fully targeted at aeronautics and aviation. This is our world ranking 2 years ago in 2023. According to the Shanghai ranking, global ranking of academic subjects, we were ranked number 24 in aerospace engineering worldwide. And of course, we are number 1 in Hong Kong. So recent years, PolyU has formulated 7 so-called strategic research domains. And as you can see, aerospace and aviation take up 2 of them. So it is expected that aeronautics and aviation will be a focusing area at PolyU and in Hong Kong. So in our department, we've got 6 major research areas, including aviation engineering, satellite communication and navigation, aerodynamics, flight mechanics and control, aerospace structures and materials, and aerospace propulsion and combustion. So I will briefly talk about some details in those research areas related to aerospace engineering. I think my colleagues have already introduced aviation engineering. So in terms of satellite communication and navigation, we are working on a full spectrum from receiver design to positioning and navigation to mapping and sensor fusion to integrity monitoring. So the applications range from smart devices, autonomous driving, UAV, of course, and civil aviation, traditional civil aviation navigation. This is a quite remarkable achievement. So in recent years, we have been collaborating with Huawei, in positioning in smartphones. So positioning algorithms developed by our colleagues have been directly used in Huawei's smartphones. In this slide, I list some highlights in aerodynamic research. So we particularly focus on high-speed flow or hypersonic flow. So hypersonic flow is the flow where the flow velocity is at least 5 times speed of sound. so it's extremely fast. And hypersonic flight technology is extremely important to national aerospace security and development, and it has become uh, a trending topic in the field of aerospace engineering. So we have developed acoustic meta materials for flow control, particularly laminar to turbulent transition. And at super high velocity, air is not just regular air at room temperature and pressure. There will be so-called high temperature effects. So we account for the chemical reactions and quantum effects of air working, traveling at a hypersonic speed. We also developed some high order, high accuracy numerical schemes. So this is our major research facility in aerodynamics. We have the one and only one supersonic to hypersonic wind tunnel in Hong Kong. So it's shown in this figure. So after you got enrolled in this program, you will have access to this facility. Okay, so this is a high pressure tube. This is low pressure tube. Before the experiment, a diaphragm will separate the high pressure and low pressure here. And when the pressure difference is larger than criterion, than a critical value, the diaphragm will rupture. So high pressure gas will accelerate through the nozzle part and rush into the test section, which is the the section in black. We also got some observation window through which we can use high-speed camera to, observe the flow phenomena. For flight mechanics and control, we have been developing control algorithms for the so-called VTOL UAV, where VTOL stands for vertical takeoff and landing. We are also developing, use multiple UAVs for target surveillance. Another research highlight is to achieve UAV autonomous flight in unknown environment using the so-called simultaneous localization and mapping technique, or SLAM technique. We also focus on the development of multifunctional nano composites. So we manipulate the microscopic structures of the material to achieve macroscopic multifunctions. For example, we can manipulate the optical absorption to achieve super black and super white materials. We can also manipulate thermal conductivity and electrical conductivity. This is another highlight. Some of our colleagues have achieved the first oblique detonation engine demonstration experiment in the world. So this is a very special cutting edge engine called oblique detonation engine operating at hypersonic speed. And this is the first demonstration experiment to show that this new type, this novel engine indeed works. So recently we signed a collaboration agreement to establish a research center with the Chinese Sixth Institute, which is the company to develop Long March rockets. So we received several projects funded by the Sixth Institute. If you are interested, and you can choose the so-called dissertation mode to get involved. Later, I will talk about the dissertation mode. So considering the rapid growth of aerospace industry in both China and Hong Kong, we believe that it is time to initiate this standalone MSc program. Perhaps you know that in this year we only have one MSc program called MSc in Aviation Engineering with two specialisms. The first specialism is with aeronautical engineering, and the second is with aviation operations. So now we separate the MSc program into two. So now we got a standalone program focusing on aerospace engineering only. I think this is also the first comprehensive MSc program in Hong Kong, covering both aeronautics and astronautics. They are also, well, as you can tell from the name, aerospace engineering. So here is the subject list or the curriculum. We divide all the subjects under this program into two parts, core subjects and elective subjects. There are 6 subjects, core subjects, including guidance, navigation, and avionics, aircraft structures and materials, flight mechanics and control, aircraft engine systems and combustion, compressible aerodynamics, and satellite engineering. So they are core subjects. We also got several elective subjects ranging from aircraft design, AI, which is a trending topic in almost every field, CFD, which is a supplementary to the theoretical aerodynamics in core subjects. Spacecraft propulsion system. So a space counterpart to this aircraft engine system, which is an aeronautical application. We have spacecraft dynamics. You can consider this as a space counterpart to flight mechanics in atmosphere. And eventually, we have a subject called engineering, computations, and modeling. So where you will leverage MATLAB, this kind of scientific computing software, to to solve multiple mathematical and physical problems. Here are some basic information. We provide 2 modes of study, full-time and part-time. So for full-time students, normal duration is 1.5 years, and it is 2.5 years for part-time students. So 3 semesters for full-time and 5 semesters for part-time. You need to fulfill 30 credits, and each subject has 3 credits. So in other words, you need to take 10 subjects plus 1 credit with respect to academic integrity. So we provide 2 options. Option number 1, you take 10 subjects, including 6 core subjects, plus 4 elective subjects, all right, from the previous subject list. We also provide the second option. You need to take 7 subjects, including 6 core subjects, plus 1 elective subject, and a dissertation. So the dissertation is equivalent to 3 subjects. When you choose option 2, as a full-time student, your normal duration will be extended to 2 years. So in our design, you need to finish. You'd better to finish all the 7 subjects in the first year, and in the second year, you can stay focused on the dissertation or research. You can stay on the research topic. So this year, for the 2025-26 admission, the tuition fee is 6,600 per credit for both local and non-local students. And the deadline is next month, April 30. We only got limited quota, 60 in total. Now we have almost fill up the quota. So if you're interested, please do hurry up. So for those who choose the dissertation mode, the second mode where you need to take a dissertation, we provide the so-called department dissertation scholarship. The scholarship selection is merit-based, particularly on your GPA. If you got selected, you will be funded 5,000 Hong Kong dollars per month up to 1 year. So it means that you will receive scholarship in the second year of study, covering your dissertation study. Here in this slide, I gave the entrance requirements. So you need to have a bachelor's degree in engineering, science, or technology. So for those who do not have bachelor's degree in the STEM field, we also give special consideration to candidates who have relevant working experience. For example, you are an engineering, aerospace engineer, or aircraft maintenance engineer. So the minimum minimum English language requirement is 80 for TOEFL and 6 in IELTS. So for any inquiries about application and admission, please contact the AR, Academic Registry of PolyU. And in terms of program information, you may either contact the General Office of AE or to the program leaders, me and Dr. Guan.